Hi, I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I wish to tell about the topic which is in the quantum mechanics. So, we are going to see about the numerical problems in quantum mechanics in the second part. That is, in previous session, we have discussed about the numericals, which is related to the de Broglie wavelength and all. So here we are going to see some more problems which is related to the particle in one dimensional or infinite potential parts and other problems, and we are going to calculate the energy levels of a particle with different energy states in different energy states. So how the energy of the particle being in the ground state and excited state. So these are what we are going to calculate in this session. So first of all, we shall see about the formula which is related to the quantum mechanics. So here the first formula, E is equals to n square h square by 8m l square. So here n is equals to 1 means that for n is equals to 1, so which is for one dimensional, so n is equals to 1, it means that the particle is in the ground state. But already we have seen that if n is equals to 0, the energy becomes 0, so there is no zero energy of the particle being in the energy level. Excuse me. So no zeroth energy level, no the particle energy will not be zero inside the potential box, so that n is equals to does not exist, so that n is equals to 1. So that's why we have taken n is equals to 1, 2, 3 and so on. So that if n is equals to 1, so it tells about the ground state, and L is the width of the box, and m is the mass of the particle, and we know that h is Planck's constant. N is equals to state of that particle, and h is the Planck's constant, m is the mass of the particle, L is the box width. Okay, so this can be written as in simplifying this, we can take the formula. So En is equals to n square En. En is equals to n square En. So that is if E1 is equals to something value, so E2 will be 4 E1. So that is E2 is equals to 2 square E1. So in this case, it is equals to 4 E1. So like that, E3 is equals to 3 square E1. So 9 E1. So as like that, E4 is equals to 4 square E1. So that is equals to 16 E1. So like that, the energy will be separated. The energies will be separated, increasing the energy states. Okay, so the energy levels will be like this. Okay, so the energies will be vary like this. So at n is equals to 2, n is equals to 1, the energy is E1. So at n is equals to 2, it is excited state, that is first excited state. So the energy will be 4 E1, and the second excited state E2. So 2 square E1, that is equals to 4 E1. Like that, we can calculate for the different energy levels of the particles' energies. So here, if we take the particle which is in three dimensional, then E is equals to n x square plus ny square plus nz square into h square by 8ml square. So that so if we are using three dimensional for the three dimensional case, so we take this formula E is equals to nx square plus ny square plus nz square into h square by 8ml square. Okay, so and we already seen in the previous problems, lambda is equals to h by root 2 mev. So this formula can be taken when the particle is experiences some potential energy v. So if the particle is accelerating with potential energy, so in that case, to calculate the wavelength of the particle, we use this formula lambda is equals to h by root of 2 mev. So E is the charge of the electron, V is the potential energy, M is the mass of the particle, H is the Planck's constant, where lambda is the wavelength which we are going to calculate about the particle. And lambda is equals to H by mv. So H is the Planck's constant, M is the mass of the particle, and V is the velocity. So also this can be written as lambda is equals to H by V. So momentum. So E is equals to mv. Lambda is equals to h by root 2me. So A is the energy. Here lambda is equals to h by root of 2mv, which we have already discussed here. Okay, so then lambda, another formula, lambda is equals to 12.26 by root v. So here for an electron, we can calculate, we simplified, after simplifying the standard values, substituting the standard values, we get lambda is equals to 12.26 by root v angstroms. So that is, we know lambda is equals to h by root of 2 mev. So in this case, substituting the h value is nothing but 6.625 into 10 power minus 34 joule second divided by root of 2 into electron mass 9.1 into 10 power minus 31 kilogram into E is the charge of the electron. So 1.6 into 10 power minus 19 into V. So that after calculating all these values, we'll get 12.26 divided by root V. So this is the simplified formula by when we got when using the standard values. Okay. So in this expression, in this formula, we substituted all the standard values of the particle of electron. So then the simplified formula will get lambda is equals to 12.26 by root v angstroms. And then kinetic energy is equals to half mv square. So mass of the particle v is the velocity of the particle. So the problem 1, calculate the velocity and kinetic energy of an electron having wavelength of 0.21 nanometers. So here the given data is lambda. So lambda is equals to 0.21. That's why. So electron having wavelength of 0.21 nanometers. So lambda is equals to 0.21 nanometers. So this can be converted into meters. So 1 nanometer is equals to 1 nano is 10 power minus 9. So it is 0.21 into 10 power minus 9 meters. So we have to calculate kinetic energy of the electron and velocity of electron. So formulas we are going to use is lambda is equals to h by root 2me. So we know the wavelength. We know the wavelength and we know h m, but we don't know the energy value. This energy, kinetic energy, we need to find. So that by simplifying this, taking E value, that is energy from this formula, take it out. So E is equals to h square by 2m lambda square. So substituting the values, as we know that h is equals to 6.625 into 10 power minus 34 joule second, and m is equals to mass of the electron 9.1 into 10 power minus 31 kilogram, and we know that wavelength, so 0.21 into 10 power minus 9. So h square means 6.625 into 10 power minus 34 whole square divided by 2 into m is 9.1 into 10 power minus 31 into wavelength square, so 0.21 into 10 power minus 9 whole square. So when calculating or simplifying this, so 6.625 into 6.625 will get 43.890 into 10 power minus 68 divided by 18.2 into 0.0441 into 10 power minus 49. So calculating these values will get 5.468 into 10 power minus 20 joules. This is the energy. So energy of the electron. So now we need to calculate the velocity. For that we are using E is equals to half mv square. E is equals to half mv square. So from this we have to calculate the velocity. So v square is equals to 2e by m. V square is equals to 2e by m. So that implies v is equals to root of 2e by m. So that instead of root, I have taken 2e by m whole power 1 by 2. So velocity is equals to v is equals to 2 into energy which we got here 5.468 into 10 power minus 20 divided by m is 9.1 into 10 power minus 31 whole power half. So simplifying this, 1.2017 into 10 power 11 whole power half. So we got the velocity v is equals to 0.346 into 10 power 6 meters per second. So likewise we can calculate when wavelength has been given, we use the h value, mass of the particle and charge of the particle. So we can find easily the energy and the velocities of the particle. And coming to the second problem, calculate the velocity and kinetic energy of an electron of wavelength 1.66 into 10 power minus 10. This is also the same. This is also the same as like the first problem, but here I used a different formula for the same thing. So in this also we can get the same values. So either we can solve in previous problem, like the previous problem, or else we can use the formula here lambda is equals to h by m. So first of all, we shall see that what are the data given here in the problem. So calculate the velocity and kinetic energy of an electron of wavelength 1.66 into 10 power minus 10. So wavelength 1.66 into 10 power minus 10 nanometers. So not 10 nanometers, meters. So already it has been given meters. So no need to change into in another units. So that lambda is equals to 1.66 into 10 power minus 10 meters. So needed to calculate the kinetic energy and the velocity. So formula we are using here, lambda is equal to h by mv. So from this we know the lambda, we know h and m. So but we need to calculate the velocity, so that v is equals to h by lambda m. So substitute the values 6.625 into 10 power minus 34, which is the value of Planck's constant, and m is 9.1 into 10 power minus 31. Lambda is 1.66 into 10 power minus 10. So calculating these values, we got the velocity value v is equal to 0.438567 into 10 power 6 meters per second. Now we are going to calculate kinetic energy. So formula is Ke is equals to 1 by 2 mv square. So m is 9.1 into 10 power minus 31. V is 0.438567 into 10 power 6. 10 power 6 whole square divided by 2. So that it is equals to 3.99096 into 10 power minus 90 divided by 2. So it is equals to energy we got here 1.9955 into 10 power minus 90 joule. So here it is taken in joule. So if we want to calculate in electron volts, so we need to divide with 1.6 into 10 power minus 90. Then we'll get the value in electron volts. That is the energy value we'll get in electron volts when we divide this value with 1.6 into 10 power minus 90. Because 1 joule is equals to 1.6 into 10 power minus 90 electrons. So third one, obtain de Broglie wavelength of neutron given that kinetic energy of the neutron is 0.025 electron volts. Mass of the neutron is 1.674 into 10 power minus 27 kilogram. So the data which is given, kinetic energy and then mass of the neutron. So kinetic energy given in electron volts. So E is equals to 0.025 electron volts. So I'm converting into joule. So that multiplying this 0.025 with 1.6 into 10 power minus 19 will get the energy in joules. And mass of the neutron Mn is equals to 1.674 into 10 power minus 24, which is given in the problem. So the formula I'm using here, lambda is equals to h by root 2me. So we need to calculate the wavelength, de Broglie wavelength of neutron. So here we know energy, and we know the mass, and we know the Planck's constant. So let's substitute 6.625 into 10 power minus 34 divided by root of 2 into 1.674 into 10 power minus 27 into 0.025 into 10 power minus 9 whole square. So the wavelength of the neutron lambda is equals to 2.8625 into 10 power minus 10 meters, which is calculated from this h by root of 2me. So substituting h value, h is equals to 6.625 into 10 power minus 34. And m is equals to 9.1 into 10 power minus 31 kilogram. And E already given 0.025 into 1.6 into 10 power minus 90. Minus 90. So here in electron volts given. So in joules I am calculating. So if I want to use this, here we need to use 0.025 into 1.6 into 10 power minus 19 whole square. So here also 1 point. So it is equals to 6.625 into 10 power divided by root of 2 into 1.674 into 10 power minus 27 into 0.025, 1.6 into 10 power minus 19. Sure. So as here I've taken in joule, H have been taken in joule. So that's why I'm taking this energy also in the joules. That is the reason why I have to multiply with 1.6 into 10 power minus 19. So 6.625 into 10 power minus 34 divided by, so here root of 2 into 1.674 into 10 power minus 27. So 6.25 into so it is equals to 6.625 into 10 power minus 34 divided by, what's this value? 2 into 1.674. 2. 6.25 root 0.20.925 into 10 power minus 65. So 6.625 into 10 power minus 34 divided by, so it is the value of root of 20.925. So 4.574 into, so which we got into root of this value 20.925 into, so the value is 1.4465 into 10 power minus 32. So we'll get 6.625 divided by, so 4.5798 into 10 power minus 2 joules. So this is the value which we got. Wavelength of neutron. Okay. So since I mistaken here, I didn't take the 1.6 into 10 power minus 19, so that I cancel here. So substituting H is 6.625 into 10 power minus 34. Root of 2 into m is 1.674 into 10 power minus 27 into the value of energy which we take converting into joules. So this value. So 0.025 into 1.6 into 10 power minus 19 whole square. So calculating this value, we got the wavelength of the neutron 4.5798 into 10 power minus 2 joules. So this is the solution. So an electron is bound in one-dimensional box of size 0.41 nanometer. What will be its minimum energy? So given that one-dimensional box, electron bound in one-dimensional box. So the width is L is equals to 0.41 nanometers. So nanometers will be converted into meters. So 1 nano is 10 power minus 9 meters. So it is equals to 0.41 into 10 power minus 9 meters. So we have to calculate the energy and the velocity. So energy of the particle which is in the potential box is equals to excuse me, n square h square by 8m l square. So it is equals to n is equals to 1. This is the minimum energy. So minimum energy will get at n is equals to 1. So E1 is equals to 1 square into, so that is E is equals to n square h square by 8m l square. This is the formula to calculate the energy. So it is equals to 1 square into 6.625 into 10 power minus 34 whole square. This is the value which is for Planck's constant, divided by 8 into m is 9.1 into 10 power minus 31 into 0.41 into 10 power minus 9 whole square. So it is equals to 0.346 into 10 power minus 18 joules. So next one, calculate the energy of the electron in the energy level immediately after the lowest energy level confined in one-dimensional box of size 0.1 nanometers. So with this 0.1 nanometer, so it is equals to 0.1 into 10 power minus 9 meters. So here the electron, we have to calculate the energy of the electron which is in the energy level immediately after the lowest energy level. So that n is equals to 1 is the minimum energy level, that is lowest energy level. Lowest energy level, that is n is equals to 1, will get n is equals to 1 means it is ground state. So n is equals to 1, if we put, we'll get the value of the energy of the particle at the ground state. This is the minimum energy, that is lowest energy. Lowest energy. So we need to calculate the energy level immediately after the lowest energy level. So after the lowest energy level means that after the ground state. So n is equals to 2. We need to calculate the energy at n is equals to 2. So this is the immediately occurs after the lowest energy level, that is ground state to excited state. So n is equals to 2. N is equals to 2 is the energy level which is immediately after the lowest energy level. So for n is equals to 2, we need to calculate energy. So formula I am using here, E is equals to n square h square by 8ml square. So n is equals to 2. So 2 square into 6.625 into 10 power minus 34 whole square divided by 8 into 9.1 into 10 power minus 31 into 0.1 into 10 power minus 9 whole square. So calculating these values, will get the energy of the electron which is immediately after the lowest energy level 24.08 into 10 power minus 80 joules. So here an electron is bound in one dimension, infinite well of width, 1 into 10 power minus 10 meters. Find the energy values in the ground state and first two excited state. So the box is electron is bound in the infinite one dimensional potential box. So width is L is equals to 0.1 into, so we need to calculate 1 into 10 power minus 10. So 1 into 10 power minus 10. L is 1 into 10 power minus 10 meters. So we need to find the energy values in the ground state and the first two excited state. So if n is equals to 1, we will get the energy at a ground state. Okay. If n is equals to 2, we will get first excited state. N is equals to 3, second excited state. So we need to calculate ground state energy, then first two excited states. So first excited state and second excited state. So that's why for n is equals to 1, we get E1. For n is equals to 2, energy E2. For n is equals to 3, energy E3. So formula I'm using, En is equals to n square h square by 8m L square. So substituting, E1 is equals to n square is 1. So 1 square into, that is, this is for ground state. That is at n is equals to 1. Divided by 8 into 9.1 into 10 power minus 31 into 1 into 10 power minus 10 whole square is equals to 0.6031 into 10 power minus 17 joules. So likewise, E2 is equals to, that is n is equals to 2, we'll get E2. E2 is equals to 4E1. So 4 into 0.6031 into 10 power minus 17 joule. So it is equals to 2.412 into 10 power minus 17 joule. And n is equals to 3, second excited state. E3 is equal to 9E1. It is equals to 9 into 0.6031 into 10 power minus 19, minus 17 joule, that is equals to 5.428 into 10 power minus 17 joules. So this is the energies of the electron bound in one dimensional infinite well, E1, E2, E3. Next, calculate the energies that can be possessed by a particle of mass 8.5 into 10 power minus 31 kilogram, which is placed in an infinite potential box of width 10 power 9 meters. So given data, mass of the particle m is equals to 8.5 into 10 power minus 31 kilogram. Width of the box L is equals to 10 power minus 9 meters. We need to calculate n is equals to 1, E1, n is equals to 2, we'll get E2. So that is, we need to calculate the energies. Here, they didn't mention that at which energy level we need to calculate, but here overall he asked about calculate the energies. So that I'm taking here two energies, n is equals to 1, at n is equals to 1, and at n is equals to 2. So E1 and E2. So the formula E is equals to n square h square by 8m L square. So E1 is equals to, when n is equals to 1, E1 is equal to 1 square into 6.625 into 10 power minus 34 whole square divided by 8 into 8.5 into 10 power minus 31 into 10 power minus 9 whole square. So simplifying this, we get 43.8906 into 10 power minus 68 divided by 68 into 10 power minus 31 into 10 power minus 8. So the value of the energy at n is equals to 1 is 0.64545 into 10 power minus 19 joule. At n is equals to 2, E2 is equal to 2 square into 6.625 into 10 power minus 34 whole square divided by 8.5 into 10 power minus 31 into 10 power minus 9 whole square. So that is equal to 4 into 43.890616 into 10 power minus 68 divided by 68 into 10 power minus 31 into 10 power minus 18. That is equal to 2.52818 into 10 power minus 90 joules. These are the energies of the particle which have the mass 8.5 into 10 power minus 31 kilogram when placed in the potential box of width 10 power minus 9 meters. Find the lowest energy of an electron confined in a square box of side 0.1 nanometer. So one dimensional box L is equals to 0.1 nanometer, that is equals to 0.1 into 10 power minus 9 meters. But for 3D, n is equals to 1, energy is how much? So for 3-dimensional, nx is equals to 1, ny is equals to 1, nz is equals to 1. So the formula is in 3-dimensional, E is equals to nx square plus ny square plus nz square into h square by 8ml square. So as we know that nx is equals to 1, ny is equals to 1, nz is equals to 1. So that substituting E is equals to 1 square plus 1 square plus 1 square into 6.625 into 10 power minus 34 whole square divided by 8 into 9.1 into 10 power minus 31 into 0.1 into 10 power minus 9 whole square. So calculating these values, the energy of the electron, lowest energy of the electron, E is equal to 18.06 into 10 power minus 18 joule. An electron is confined in a 3-dimensional box of side 0.1 nanometer. Find ground state energy and first 3 excited state energies in electron volts. So the electron is in 3-dimensional box, so having the width 0.1 nanometer. So we need to calculate energy at n is equals to 1, that is for a ground state, and n is equals to 2 first excited state. First excited state. So when writing this Roman, we need to put ST. So n is equals to 3, second excited state, n is equals to 4, third excited state. So we need to find E1, E2, E3 and E4. So width of the box L is equals to excuse me, L is equals to 0.1 nanometer. So converting into meters, 0.1 into 10 power minus 9 meters. So for 3D, we need to calculate the energies. So n is equals to 1, ground state energy. So 3-dimensional, nx is equals to 1, ny is equals to 1, nz is equals to 1. So E1 is equals to, so formula I'm using, E is equals to nx square plus ny square plus nz square into h square by 8ml square. So all three sides 1 square plus 1 square plus 1 square into 6.625 into 10 power minus 34 whole square divided by 8 into 9.1 into 10 power minus 31 into width is 0.1 into 10 power minus 9 whole square. So the value is E1 is equals to 18.06 into 10 power minus 18. Likewise, when n is equals to 2, first excited state E2 in the same manner. So substituting 1 square, that is for n is equals to 2, we have to take nx is equals to 1, ny is equals to 1, nz is equals to 2 as one-dimensional potential box. So this the particle will be raised up in z direction, so that nz we have to take n is equals to 1 for ground, n is equals to 2 for first excited state, n is equals to 3 for second excited state, n is equals to 4 for fourth third excited state. So remaining nx and ny are being the same, so that um, square box. So first is a ground state, first excited state, second excited state, third excited state. Likewise, we have to calculate the energies. But here nx and ny, nx, ny are being the same. So for a ground state, nx is equals to 1, ny is equals to 1, nz is equals to 0. So that we'll get ground state energy. For n is equals to second, that is first excited state. So that is first excited state. Nx is equals to 1, ny is equals to 1, nz is equals to 2 because it is excited in z direction. And for the second excited state, nx is equals to 1, ny is equals to 1, and z is equals to 3. And the third excited state, nx is equals to 1, ny is equals to 1, and z is equals to 4. So likewise, the n values have to take. So now first excited state E2. So 1 square plus 1 square plus 2 square into 6.625 into 10 power minus 34 whole square divided by 8 into 9.1 into 10 power minus 31 into 0.1 into 10 power minus 9 whole square. So the value is 36.1736 into 10 power minus 19 joule. So as I have taken here the Planck's constant in joule, so that this energy will become a joules. So but here uh, the energy is asked to convey in the electron volts. So 1 joule is equals to 1 joule is equals to 1.6 into 10 power minus 19 electron volts. So that multiplying this 1.6 into 10 power minus 19 will get 22.6085 electron volts. So likewise E3, so we have to substitute ny and z is equals to 3, so that 1 square plus 1 square plus 3 square into 6.625 into 10 power minus 34 whole square divided by 8 into 9.1 into 10 power minus 31 into 0.1 into 10 power minus 9 whole square. So 66.318 into 10 power minus 19 joule, which is divided with this 1.6 into 10 power minus 19. It is equals to 41.44 electron volts. For E4, it is equals to 1 square plus 1 square plus nz is 4. So 4 square into 6.625 into 10 power minus 34 whole square divided by 8 into 9.1 into 10 power minus 31 into 0.1 into 10 power minus 9 whole square. So it is equals to 108.521 into 10 power minus 19 joule divided by 1.6 into 10 power minus 19 will get 67.825 electron volts. So these are the energies which is conveyed in electron volts of a electron confined in three-dimensional box. So these are the numerical problems related to the quantum mechanics. So in the next session, we will go for another module which is lasers. So lasers and fiber optics. So in that session, that is next session, we shall discuss about the lasers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.